Welcome to the exciting world of geocaching. What is geocaching? I'll tell you. Geocaching is a high-tech global scavenger hunt game that uses satellites and handheld GPS units to help you locate secret treasures hidden somewhere on Earth. More about that later. To fully understand how GPS, or the Global Positioning System, works, we need to cover a few basics. The Global Positioning System is actually a constellation of 27 Earth-orbiting satellites. 24 are in operation and 3 extras in case one fails. Each of these 3,000 to 4,000 pound solar-powered satellites circles the globe at about 12,000 miles, making 2 complete rotations every day. The orbits are arranged so that at any time, anywhere on Earth, there are at least 4 satellites visible in the sky. Okay, so how does that help us find out where we are? A GPS receiver's job is to locate 4 or more of these satellites, figure out the distance to each, and use this information to deduce its own location. This operation is based on a simple mathematical principle called trilateration. Trilateration in 3-dimensional space can be a little tricky, so we'll start with an explanation of simple 2-dimensional trilateration. Imagine you are somewhere in the United States and you are totally lost. For whatever reason, you have absolutely no clue where you are. You find a friendly local and ask, "Where am I?" He says, "You're 625 miles from Boise, Idaho." This might be true, but it doesn't help you too much. You could be anywhere on a circle around Boise that has a radius of 625 miles. You ask somebody else where you are, and she says, "You are 690 miles from Minneapolis, Minnesota." Now you're getting somewhere. If you combine this information with the Boise information, you have 2 circles that intersect. You must be at one of these 2 intersection points. If a third person tells you that you are 615 miles from Tucson, Arizona, you can eliminate one of the possibilities because the third circle will only intersect with one of these points. You now know exactly where you are, Denver, Colorado. This same concept works in 3-dimensional space as well, but you're dealing with spheres instead of circles. This is how global positioning works. 3-dimensional trilateration isn't much different from 2-dimensional trilateration, but it's a little trickier to visualize. Imagine the radii from the previous examples going off in all directions. So instead of a series of circles, you get a series of spheres. If you know you are 10 miles from satellite A in the sky, you could be anywhere on the surface of a huge imaginary sphere with a 10-mile radius. If you also know you are 15 miles from satellite B, you can overlap the first sphere with another, larger sphere. The spheres intersect in a perfect circle. If you know the distance to a third satellite, you get a third sphere, which intersects with this circle at 2 points. The Earth itself can act as a 4th sphere. Only one of the 2 possible points will actually be on the surface of the planet, so you can eliminate the one in space. In order to make this simple calculation, the GPS receiver has to know 2 things. 1, the location of at least 3 satellites above you, and 2, the distance between you and each of those satellites. The GPS receiver figures both of these things out by analyzing high-frequency, low-power radio signals from the GPS satellites. Radio waves are electromagnetic energy, which means they travel at the speed of light, about 186,000 miles per second. The receiver can figure out how far the signal has traveled by timing how long it took the signal to arrive. At a particular time, let's say midnight, the satellite begins transmitting a long digital pattern called a pseudo-random code. The receiver begins running the same digital pattern, also exactly at midnight. When the satellite's signal reaches the receiver, its transmission of the pattern will lag a bit behind the receiver's playing of the pattern. The length of the delay is equal to the signal's travel time. The receiver multiplies this time by the speed of light to determine how far the signal traveled. Assuming the signal traveled in a straight line, this is the distance from receiver to satellite. After the GPS receiver locates 3 or more satellites, it can now calculate its location on the Earth and give you its coordinates. And this is how we geocache. Geocachers will hide cache boxes and record the latitude and longitude of the hiding locations. This is where the fun starts. They will share these coordinates with other cachers who will use GPS receivers to locate the approximate vicinity of the hidden treasure. They simply input the coordinates and let the GPS receiver guide them to the cache box. Geocachers can hide anything from a small toy to a $100 bill for you to find. Once you have found the cache, you can choose to take a treasure or leave one. Geoetiquette says to always leave something if you take something. Don't forget to sign the logbook and to put the cache back where you found it for the next person to find. Thanks to a network of Earth-orbiting satellites and handheld GPS receivers, this high-tech game can be played all over the globe and enjoyed by all. Have fun and think about all the technology that makes this possible.